So today we're going to cover Chapter 8, Section 4, and we're going to cover proportionality theorems. So we're still talking similar triangles, but now we're going to talk about some specific proportionality theorems. So the first one is called the triangle proportionality theorem, and this one states that if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. So here, if EB is parallel to DC, then we could set up the proportion AB over BC is equal to AE over ED. Now, if you'd rather put it AE first and then ED, it doesn't matter which side you set it up as. So here, what they've done is they're taking the top piece and putting it over the bottom piece. This is usually the easiest way to set up these proportions. So this was actually the left top over the left bottom, and this is the right top over the right bottom. So that's how they set it up, top over bottom. You could also set it up side to side as well. You would still get the same answer. Now, what you need to realize is these two triangles here, this top little one compared to the whole thing, these are two similar triangles. And if the lines are parallel, I've got those congruent corresponding angles. So you could also use all your knowledge that you learned at the beginning of the chapter. So here is our AEB, and here is our ADC. And then we can see that the sides are going to be, so the angle A up here is the same. And then because we have the parallel lines, remember we've got the corresponding angles here that are congruent. So E and D would be congruent. And then same thing for B and C. These guys over here would be congruent. So we could still use our knowledge for similar triangles, and we could also have set up our proportion as doing this side here, AE over AD. Those would be the sides that match, AE over AD. And then match it here with AB over AC. Either way, you can go back and reach back. But I think it's a lot easier if you just use this triangle proportionality theorem and just do the top piece over the bottom piece. Again, you could go side to side as well. But again, I would pick one method and stay consistent. Because technically, we could also go AE over AB and ED over BC. So you could also do it AE and go side to side, and then ED over BC. Any of these will work, but find a method and stay consistent. I think the top over bottom makes most sense. Theorem is the converse of that triangle proportionality theorem. So remember, the converse switches the order. So if a line divides two sides of a triangle proportionally, then we can show that the sides are parallel. Then it's parallel to the third side. So now what they're telling us is that we have proportional sides, and then we can prove that EB is parallel to DC. So again, you can either do what they've done here is top over bottom, but again, you could go left over right. It doesn't matter. So they've done this top over this bottom for the first fraction, this one, and then they've done this top, AE, over this bottom piece for this fraction. Again, if you would have rather written the AE over ED first, and then the AB over BC, it doesn't matter the order that you put the proportions in here, or the ratios into the proportion. Let's go ahead and try and apply the proportionality theorem. So our first example here has 3 parts to it. So first it wants us to set up the proportion. Now, notice when they started out for us, we've got to match it. And what they've done here is they've taken now, instead of doing top over bottom, they're doing, this is the bottom, and this is the top. So what they did here is this is actually bottom over top. So over here, this is the bottom piece, top piece. So here we would put CE over, do EB. So if they started out, you need to match what they've done. Now, for the next part, part B, they've actually given us some numbers for these sides. I'm going to add in the numbers. I'll go ahead and label them in black here for part B. So they're giving us CD is 3, DA is 6, DE is 3.5, and AB we're going to put as X. What I'm going to be doing here is I can't use my proportionality theorem, but what I can use here is the fact that these are similar triangles. So let me go ahead and pull them apart. So I've got this little one right here, and then I can do the larger one right here. So I've got the little one, C, E, D, and then the larger one, B, A, C. And let me label the numbers. Now, AC, I can add 6 plus 3, and this side is 9. This is my X, this is my 3.5, and this is my 3. So now I'm going to match the sides. So I can see that these are corresponding. So I can put these two in the same fraction. So I can do 9 over 3. And I'm going to go ahead and get this side length ratio and simplify it and make it 3 to 1. And then these two sides will match. So I'm going to be doing 3 over 1 is equal to X over 3.5. So to find the length of X, which is AB, I'm going to cross multiply. So I'm doing X times 1 and then 3 times the 3.5. Once I multiply 3 times 3.5, I get 10.5. So the answer to part B is AB equals 10.5. Now I'm going to do part C, and I'm going to change the numbers. So let me go ahead and redraw the picture down here. So I have B, A, C, E, D, and then here, and again, they had parallel marks here. So I can go ahead and CB is equal to 12. So this whole thing is 12. EB is 8. CD is 6. And I don't know DA. So for this one, part C, I could use my proportionality theorem. So in order to find EC here, I can take 12 and subtract the 8, and this little piece is 4. So now I can use my proportionality theorem and set this up as BE over EC is equal to AD over DC. I'm doing the tops over the bottoms. So BE was 8, EC was 4, AD is X, and DC is 6. So what we could do here is you can either solve it this way, or you can choose to simplify the 8 over 4. So if I simplify the 8 over 4, this becomes 2 over 1, and then X over 6. And then when you cross multiply, it's just X equals 12. If you solved it without simplifying, the cross products would give you 4x equals 48. Divide by 4, and x equals 12. Notice it's the same answer either way. So dA here is equal to 12. This one, I applied my proportionality theorem. And the reason why I can set up my proportion this way is because those two sides were parallel. The next theorem is called the three parallel lines theorem. So if three parallel lines intersect two transversals, then they divide the transversals proportionally. So we're not dealing with triangles here. We're just dealing with three parallel lines, and it's got two transversals. But what it does is it separates it proportionally. So here, what they're still doing, these are tops over the bottoms. So this is the top portion, and these are the bottom portions. Now, they did right over left. You could also do AF and put the FE first, and then the BC over CD. Just do top over bottom. You can also reverse it, and you could also do bottom over top. It really doesn't matter. If you would have preferred to flip it and do bottoms portions over the tops, you can do that. So I could take this one and instead do those denominators in the top and then do the numerators in the bottom. You can flip the fractions, but you have to flip both. Just stay consistent. I think usually it's easier to memorize it like where it looks naturally and put the top over the bottom and think of it as the top of the fraction and the bottom of the fraction. So let's go ahead and try some examples applying this theorem. Example 2. So notice here we've got three parallel lines and two transversals. Now I'm going to go ahead and I'll do part A. I'll label all of these numbers for the variables in red. So this one's 2, B is 3, C is 5, and we don't know D. So again, I'm going to set up my proportion top over bottom. So for part A, I'll do 2 over 3 is equal to 5 over, actually I'll do it as the letter that's there, 5 over D. I'll go ahead and cross multiply. 2 times D, 3 times 5, divide by 2, and D equals 7.5 or 7.5. Let's try part B. I'll label the sides. I'll just use the same picture. I'm going to do this one in blue. So this time they've changed A to be 4. B is 8 now. C is still 5. And now they want us to find C plus D. Now I'm going to first find D, but then I need to remember to go back and add it to C. This would be a classic example you would see on a standardized test, where they don't necessarily just ask you to find one variable. They actually ask you to go back and do something with what you found and either add it or subtract it or multiply it. So again, I'm going to set it up top over bottom. So 4 over 8, 5 over D. I'm going to find D first, then go back and add it. Now, you can either choose to solve it this way, or we could also reduce 4 over 8 to 1/2, and then it's a lot easier to solve. But if I do it this way, I get 4D equals 40. The numbers here aren't too bad, but if the numbers get large on the test, you're better off simplifying, because when I solve this one, it's just 1 times D and then 2 times 5, and it went right to the answer. Now, part B did not ask for just D, it asked for C plus D, so now I have to take C, which they gave me, which was 5, and add it to the 10 that I just found, so C plus D equals 15. This one is applying the three parallel lines theorem. We have another theorem on the next slide. The next one is called the triangle angle bisector theorem. And this one states that if a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. So here in red is my ray, and I can tell that it was an angle bisector because of the congruency marks here on my angle. So I know that this is an angle bisector, and then it's going to take the side and it's going to split it into two pieces, and those two pieces are going to be proportional to the other two sides. So here what they did was the sides that got split are in the same fraction, and then the side that it's next to is going to be the other fraction. Now, what you could also do is set it up as AD, and then the side that it's next to, AC, and then here you could do the DB and the side that it's next to. Either way, either proportion, it doesn't really matter. You can also flip the fractions. You don't necessarily have to do the piece that was split. You could have done the other sides. So again, any variation of these, but you could flip them as well. So here I could flip it and do the DB over AD or the CB over the CA. Either way. So let's try some examples. This one that they gave here, it sort of even looks like the same thing we were doing before, the top over bottom. So if you think that the AD is on top of the DB, this is the bottom, and this would be like the top side over the bottom side. Maybe just try to find a way to help you remember. So let's try example 3, and we're finished with the notes. So example 3, it wants me to find, example 3 wants me to find the value of x. Notice the value of x is that whole side of the original large triangle. So for this one, what I'm going to do is I'm going to use the theorem that I just learned. I'm going to use that triangle angle bisector theorem. But what I'm going to do to make this a little bit easier, I'm going to add in, for this little piece right here, I'm going to call this y. And I'm going to apply that theorem I just learned. So what I can do here, again, if you want to do top over bottom, we could take this side, the 10, and put it over the y. So I could do 10 over y, and then 12 over 24. Now again, instead of having to multiply 10 times 24 and divide it by 12, I highly recommend you simplify. So if we reduce the 12 over 24, that'll simplify to 1/2. And then if I cross multiply, I end up with y equals 20. So again, if you wanted to think of, this as top over bottom, you could. Now, it didn't ask for y, it asked for x. So if this little piece now is 20, to get x is going to equal 10 plus 20, so x equals 30. Now, you could have also set up your proportion. You could do the 10 over 12, and then the y over 24, you can set it up that way as well. But the way I just set it up was the way it was officially presented in the example of the notes. So if you wanted to do it that way, you would have done 10 over 12, y over 24. Again, I would simplify this, 5 over 6, y over 24. If you do it this way the numbers are not as nice. So if you multiply this, I get 120 divide by 6. And I get y equals 20 this way as well. So either way, you can set these up. Just find the consistent method that you want to use for each one. So that is it for section 4. It is the last section of the chapter. So next week we will be doing some review. We will also practice proofs. You will have a proof on the test. But again, we are not going to test you yet on the system of equations. We will do a segment on review of Algebra 1 skills, of factoring, and then we'll review the system of equations again, and we will quiz you on that. But that'll be prior to Chapter 10, because you will need to factor when we start the circle chapter, which is Chapter 10.